To push a machine to the absolute limit of speed is to invite the most brutal physics on Earth directly into the cockpit. Look at the 1950s starting grids. Drivers sat high within the chassis, wrestling mechanical frames exceeding 250 kilometers per hour, completely exposed to the elements. Their personal safety gear offered absolutely zero impact protection. They relied on rudimentary cloth wraps, simple leather caps, or canvas helmets reinforced with cork. This created a total vacuum of safety. The open-air cockpit meant the driver absorbed every external threat: flying track stones, leaking fluids, and the raw kinetic energy of a crash. As engine power rapidly increased, the gap between performance and protection became unsustainable. The rising fatalities forced a shift in design philosophy, prioritizing the creation of a rigid survival cell. The first critical step toward that capsule arrived in 1968, when Dan Gurney brought the full-face helmet into Formula One. This continuous shell of fiberglass successfully shielded the driver's jaw and face from the immediate external threats of flash fires and high-velocity flying debris. As aerodynamic grip and extreme cornering velocities escalated through the 1990s, the primary physical threat shifted. It was no longer strictly external debris striking the driver. It was the invisible internal forces of rapid deceleration. The tragic events of the 1994 season provided a stark mechanical lesson. A highly rigid helmet protected the skull from direct impact, but leaving the neck completely unsupported proved fatal under high G-loads. In a high-speed impact, the torso is locked, but the helmet whips forward violently, risking a lethal skull fracture. The hand system solves this with composite tethers anchored to a shoulder collar, arresting forward momentum and transferring the immense deceleration force into the chest. By 2003, the FIA mandated this specific physical structure for every driver on the grid. Engineers recognized they had to account for the internal physics of the crash. They were now actively protecting the driver from the lethal momentum of their own body. Even with the neck secured and the skull encased in composites, a critical vulnerability remained, right over the eyes. The polycarbonate visor could still fail against small, dense metal projectiles. In 2009, a rogue steel suspension spring from another car struck Felipe Massa's helmet at high speed in Hungary, penetrating the area directly above his left eye. The FIA's immediate countermeasure was to mandate bulletproof Cylon strips across the top of the visor, ensuring localized penetration from flying debris was structurally blocked. Yet mitigating small debris left the driver exposed to massive blunt force impacts, rollovers, heavy detached wheels, and the risk of a competing car intruding directly into the open cockpit space. The solution arrived in 2018 with the mandate of the Halo, a thick, wishbone-shaped titanium structure bolted securely over the driver's head. This specific geometry is engineered to support the weight of a double-decker bus. It takes multi-ton downward and frontal forces and channels them directly into the main chassis roll hoop, physically deflecting heavy impacts away from the helmet. With ballistic Xylon over the eyes and aerospace titanium over the head, the cockpit now provides the driver's roof roll cage. All of these historical lessons culminate in the modern Formula One helmet. Today's shells are heavily reinforced with aerospace-grade carbon fiber, woven Kevlar, and advanced ballistic materials. To ensure absolute safety, they must pass brutal FIA certification. The shell is required to withstand a heavy metal projectile impacting at 250 kilometers per hour without a single point of structural failure. They are also tested against severe thermal extremes, engineered to survive temperatures approaching 790 degrees Celsius, keeping the driver's head insulated from fire. This helmet is the result of 7 decades of testing. It is a piece of aerospace equipment engineered to protect the human brain from the extreme kinetic energy inherent in modern racing. The early decades of Grand Prix racing were defined by extreme physical exposure and devastating losses. Today, drivers walk away from extreme G-force impacts that would have been mathematically fatal just 20 years ago. The modern driver and the machine operate together. The composite helmet, the hands device, the titanium halo, and the carbon chassis function seamlessly as a single integrated survival cell. This level of protection is not the result of a single breakthrough, but a continuous response to 7 decades of physical data. It stands as evidence that engineering can mitigate the risks of extreme speed. If you found this journey through the evolution of Formula One safety inspiring, make sure to like this video, share it with a fellow racing fan, and subscribe to the channel for more untold stories of engineering valor.